Hello guys, my name is Faisal and I'm here to explain about the PASS test 2 in 2017 and 18. Question 1. You're given this equation d squared y over dx squared plus c squared y is equal to sec squared cx, where c is higher than 0. So you're told to find what is the c, where w is equal to 3, and then you're told to find the solution of the equation. So we have two parts. We find c and we find the solution of the equation. First step, we have to write the homogeneous, to solve the homogeneous part, okay? We write this in the form of m squared plus, since here there's no differentiation, it's just c squared is equal to 0. Now when I take it to right hand side, m squared is equal to c squared minus m is equal to ci plus or minus. So this is in a complex expression. Now to write the homogeneous of complex expression, here is the general one. It says e alpha x into bracket a sine beta x plus b cos beta x. Now for the general expression of the complex expression, it is in this form: alpha plus or minus beta I. So in our expression, alpha is 0, beta is c. So this can be written as e power 0 a sine cx plus b cos cx. By simplifying, this becomes a sine cx plus b cos cx. Now, to find the c, since we have w, we will use the equation of the w, okay? Whereby you need to have y1 and y2. So, for me, I would take y1 as cos cx and y2 as sine cx. So the differentiation of y1 is minus c sine cx. The differentiation of y2 is c cos cx. Now the formula for w is in like this, is in a matrix form, and you have to find the determinant, which is y1 y2 dash minus y2 y1 dash. So from this directly we can take what is our y1 is cos cx, y2 dash is c cos cx minus y2 is sine cx, and y1 dash is minus sine cx. Now by simplifying this, you get cx squared plus c sine squared cx. So continuing, w is equal to, I take out the c from here, so this becomes c cos squared cx plus sine squared cx. Now from this expression, you will see that cos squared and sine squared, from the identity of trigonometry, cos squared x plus sine squared x is equal to 1. So this whole thing becomes 1. So c is equal to w. Now c is w. What is our w? W we are given as 3. So c is equal to 3. After finding c, we solve the equation. We can solve the equation by using these two expressions. Ux is equal to minus integral of y2 f of x over a w dx. A, if you know, is the coefficient of d squared y of dx squared, which is 1. Fx is the sec squared 3x, okay? And y2 is this y2, sine 3x. So we put it together. y2 is sine 3x. F of x is sec squared 3x over a is 1 and w is 3 dx. Now I take out the 3 outside, then this becomes sine 3x. Sec squared 3x becomes 1 over cos squared 3x dx. And then this I can simplify as sine 3x over cos 3x times 1 over cos 3x dx. You can simplify this more by writing tan 3x sec 3x dx. So I let first u be equal to 3x. du is equal to 3 dx. So my dx will be du over 3. Over 3, this is tan u sec u dx, as we said, is du over 3. I can take out the 1 over 3 outside. It becomes 1 over 9 integral tan u sec u du. So integrating this, according to the table, integration of tan u sec u is sec u. So I just write here directly 1 over 9. The integration of this is sec u. And I substituted back sec u, u, which is 1 over 9 sec 3x. Now this is our ux. Now for the other expression, vx is equal to integral of y1 f of x over aw dx. So y1 is cos 3x, f of x is sec squared 3x over 3 dx. Now I can take out the 3 outside, okay, and this becomes 1 over 3 integral of cos of 3x times 1 over cos 3x dx. So cos 3x and this one cancel out, so it becomes 1 over 3 integral of 1 over cos 3x is sec 3x dx. After that, I need to change this into u, so I let u be equal to 3x. du is equal to 3 dx. Okay, so I substitute the u inside. It become 1 over 3 integral of sec u du over 3. dx is equal to du over 3. So I take out the 1 over 3, becomes 1 over 9 integral sec u du. Now in here, there are two methods to solve integration of sec of u. One method is long, the other method is short. I will take the second method. So for the second method, since here there's a 1 multiplied here, okay, I can manipulate this 1 into either any expression, divide by any expression, meaning let's say x squared plus 1 over x squared plus 1, or sine x plus cos x over sine x plus cos x, anything. So what I do here, I write sine u plus tan u over sec u plus tan u du. These are the same, they cancel, okay, it becomes 1. So nothing changed. Now from here, I will let again another variable be equal to this at the bottom. So let v be equal to sec u plus tan u. When I differentiate this, dv is sec u becomes sec u tan u. And when I differentiate tan u, I get sec squared u. And this becomes du. Now substituting into the equation, and when I get du from here, in order to simplify, I get dv over sec u tan u plus sec squared u. So I'll substitute things inside. Now from here, I can put the sec u inside, becomes sec squared u plus sec u tan u over. This whole thing becomes a v, since before we let it be like that. And then I will substitute the du with dv over sec u tan u plus sec squared u. This whole thing cancel with this whole thing. The only thing that remains is 1 over 9 integral of dv over v. When I integrate this, I get ln of v, which is 1 over 9 ln of sec u plus tan u. And what is my u? My u is my u is 3x plus tan 3x with the absolute value. This is your vx. Now to find yp is u y1 plus v y2. So u from before, it was minus 1 over 9 sec 3x. y1 is cos 3x plus v is 1 over 9 ln of sec 3x plus tan 3x, and y2 is sine 3x. Simplifying this further, I take out 1 over 9 outside, becomes 1 over 9, okay? And here sec u is 1 over cos u. Cos and cos will cancel, so it only becomes 1. So I have here ln sec 3x plus tan 3x. Sine of 3x minus 1. So this is our yp. Now for the final answer, y is equal to, you add the equation of homogeneous and the equation of non-homogeneous, which is yp. So yh is a sine 3x plus b cos 3x plus yp is this one. So 1 over 9 into bracket ln of sec 3x plus tan 3x sine 3x, okay, minus 1. So this is your whole equation, which is the answer.